What if I told you you can manipulate numbers at their most fundamental level? Not decimal, not strings, but the actual bits underneath. In today's video, we are going one layer deeper on how your computer really works. Hello learners, welcome to your learning hub, the Learning Loop. I am Swati Sharma and this is the 23rd video of my beginner friendly Python course series. If you are joining me for the first time, thank you for dropping by. And if you haven't checked out my previous videos yet, I would highly recommend you to go back and check those out so that you are all caught up. Before we proceed with the video, if you haven't subscribed my channel yet, please go ahead and press the subscribe button and hit the bell icon so that you do not miss out on any future videos. In today's video, we are going to learn about bitwise operators in Python and how they operate at bit level. So, without a further ado, let's dive in. Let's first understand what are bitwise operators. Bitwise operators let Python perform operations directly on the binary representation of numbers, that is zeros and ones, the way computer actually stores them. Computer does not understand the decimal format of numbers, that is 5, 10, 100. The computer actually understands 0 and 1. And bitwise operators allow us to directly manipulate these zeros and ones. Some of the use cases of bitwise operators is image processing, cryptography, embedded systems, permission systems where we want to grant permissions like read, write, or execute. Now, just to be clear, some of the use cases that we mentioned, like image processing or cryptography, are more advanced topics. I don't want you to feel overwhelmed or intimidated by them. The goal of today's video is not to master bitwise operators. The goal is to know that they exist. I want you to understand that these operators exist and they work at the bit level and to see clearly how they actually operate. So that in future, if you ever come across them in project, in documentation or an interview, you are not confused or stuck thinking, what is this? Instead, you will recognize them and you will know what exactly it does and you will know how to approach it. Before we understand bitwise operators, we first need to understand the number systems. This section is especially for anyone who's coming from the non-technical background and is not aware of the number systems that are being used in computing. If you are aware of the number systems, especially binary and decimal number system that are used in computing, feel free to skip this section to the next one where we are discussing the types of bitwise operators. In computing, there are 4 number systems: decimal, binary, octa, and hexadecimal. In this video, we will only be discussing decimal and binary because these two are actually relevant to the bitwise operators. But if you would like me to cover all the 4 number systems, including hexadecimal and octal number system, please comment below and I can definitely take up a separate video to explain these number systems in detail. Now, in our day-to-day life, we use decimal number system. Now, decimal number system is base 10. Base 10 means that you can have 10 unique representation of digits. That is from 0 to 9. That is why whenever you do 9 plus 1, now we don't have any single representation of this number. So it resets or takes up the new position and goes as 10. Same goes with 99. Now that we have exhausted all the numbers in the new position as well, the new position is created and the next number goes as 100. Now for binary, the base is 2. That is only 2 digits are allowed, that is 0 and 1. And binary in itself is self-explaining. Bi means 2. Now, same ways, the way it happened in the decimal system, that any time it exhausted the digits, it took up the new position. The same thing happens with the binary number system as well. As soon as it exhausts the digits in its first position, it will take up the next position. So if I go 0, 1, and if I do +1 here, it will reset and the next representation would become as 110. In this video, I would only be showing the basic counting, how the counting works and how this is related to decimal number system, and not going too deep into how we can do the conversions from one number system to another. However, if you would like to have a video on that, please feel free to comment below and I can definitely take the number system topic as a separate video or separate playlist on that, so that you can learn all the number systems and we can go in details like how the conversions can be done from one number system to another. So let's quickly understand how the counting works in binary number system and how they are presented in decimal number system. Let's do side by side presentation of binary and decimal number system and understand uh, how the counting happens in decimal. We are aware of how counting happens in decimal and how it happens in binary. Okay. So let's take decimal on this side and binary on the second side. As we have already discussed, decimal is base 10, which means it will has 10 unique numbers or numbers in it, which is from 0 to 9, right? So how we present it? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now that we have exhausted all the digits in this position, if I do +1, the number in this position will reset to 0, and now the new position will take on the left side. We will have new position coming up and it would be 10, which we call as ones, tens, right? So new position would be taken at the tens position because we have exhausted all the digit on the ones position, right? Same ways, binary, as we have already discussed, binary is base 2, which means at maximum it can only have two digits, that is 0 and 1, right? So the 0 in binary would be presented as 0, the 1 would be presented as 1. Now here's the twist. Now because we have exhausted all the digits as per the binary number system, we have only allowed only 2, 0 and 1. Now if I do 1 plus 1 here to present 2 in the decimal number system, or if I want to present the 2 in decimal number system in binary, how that would be written in binary. So if I do +1, obviously the number system resets. On the ones position, the number system resets to 0 and the new number comes at the tens position. So the presentation would be 1, 0. In binary number system, we don't call it 10, 11 or anything. We call it 0, 1, and then now this presentation is called 1, 0. Now the 3, if I do +1 here, obviously 0 plus 1, 1, and then 1. 3 would be presented as here 1, 1. 4, again you can see we have exhausted both. We have exhausted the numbers on both the positions. Now if I do +1 here again, it would be 0, 1 carry forward, 1 plus 1 0, and we will have 1. So it would be presented as 1, 0, 0. 5 would be represented as 1, 0, and now +1 here would be 1, 0, 1. Okay, now let's check out how the 6 would be presented. 1 plus 1, 0, 1 carry forward, 1, 1, 1, 1, 0. 7 would be presented as 1, 1, 1 plus 1 in the 8. We would have 1, 0, 0, 0. You see how this is working here? Now, this 1 0 in binary is actually 2 in decimal. It's just that we are presenting 2 as 1 0 in binary, but it would be read as 2 when we are doing the conversion from binary to decimal. It would come out as 2. 1 1 would come out as 3. Okay, so when we are using bitwise operators, so the actions are happening on these bits, that is 0 and 1, and the same way I'm showing you, there are different operators that we are using, and according to that the actions will be taken, and we would be discussing that. But the answer would be presented in decimal number system. Okay, the answer that you would get would be a decimal number. Okay, let's quickly check out the types of bitwise operators and see how they work, and also explore a few examples. There are 6 types of bitwise operators: bitwise AND, bitwise OR, bitwise XOR, bitwise NOT, left shift and right shift. Let's discuss each one of these in detail with examples. The first one is bitwise AND, which is presented using the AND symbol. Let's understand how this works. Let's say I write a code print 4 and 3. Okay. Now, because the bitwise operators work at the bit level. Okay. So, what bitwise operator would do is we'll take these numbers to the bit level. Now, 4 in binary format is presented as 1 0 0, and 3 in binary format is presented as 1 1. I will set the third bit as 0 because nothing is there. And now we'll perform this AND operator. Now let's understand what this AND operator says. AND operator says if both the bits are 1, only then the bit would be set as 1. If any of the bit is 0, the answer would be 0. Right? So if I'm doing 1 and 1, the answer would be 1. 1 and 0, the answer would be 0. 0 and 1, answer would be 0. Obviously, 0 and 0, the answer would be 0. In our case, we can see it is 1 and 0. We will start from the right, I'm sorry. 1 and 0, 0. 0 and 1, 0. 1 and 0, 0. In the binary format, this is coming as 0, 0, 0, which in decimal would come out as 0. Now, you need not to calculate that. It's just for your understanding what is happening in the background. So, once I print this, you should see the answer as 0. Let's quickly check that. You can see the answer is 0 because none of the bits were 1 and 1. Let's take one more example. I do print 5 and 3. Okay. Let's again try and count the bits. So 5 in binary is presented as 1 0 1 and 3 as 0 1 1. Now this is 1 and 1. We are doing AND here. So 1 and 1 would be 1 0 1 0 1 and 0 0. So answer should be 1, decimal 1, because in binary 001 would be coming out as decimal number 1. Now note that bitwise operators do operate at bit level, but the answers that you are getting would be in a decimal format. So that's why you see it here 0 and the next one you would see at 1. If I take another example, let's say if I do 6 and 3, right? 6 would be 1 1 0. That would be a decimal 6, right, in binary. And 3 would be 0 1 1. Then it would come 0 and 1 as 0, 1 and 1 as 1, 1 and 0 as 0. Now this is 010 in binary is 2 in decimal. So you would get the answer as 2. So whatever you're doing, everything is happening in the at the bit level, but the answers are being presented in the decimal format. So I'll give you the example for 6 and 3 as well, so you can check that. Let's first do the print 5 and 3, and you can see the answer is 1. And as we also saw the example for 6 and 3, and the answer should be 2. I'll print it and you would see the answer is coming as 2. Now let's take the next bitwise operator, that is bitwise OR. And bitwise OR is presented using the pipe symbol. So let's take an example. Let's take the same example that we have above, that is now would be 5 or 3. Now let's understand what does OR does in the background. Bitwise OR says if any one of the bit is 1, the answer would be 1. The only time the answer would be 0 is both the bits are 0. So which means if I do 0 or 1, the answer would be 1. 1 or 0, the answer would be 1. 1 or 1, the answer would be 1. And 0 or 0, the answer would be 0. The only time the answer would be 0 if both the bits are set to 0. Now let's look at our example. 5 or 3. Now 5 in binary is presented as 1, 0, 1. And 3 in binary is presented as 0, 1, 1. So the answer would be 1 or 1. So it is, we are using OR here. So 1 or 1, 1. 1 or 0 or 1, 1. 1 or 0, 1. Which is 1, 1, 1 in binary is 7 in decimal. So if I do 5 or 3, we will get the answer as 7. Let's check that out. And run this and you can see we got the answer as 7. The next one is Bitwise XOR. This Bitwise XOR is presented using the caret symbol. Let's now quickly go for an example, and again we will take the same example, 5 XOR or Bitwise XOR 3. Now let's understand what exactly XOR does or how XOR operates. So XOR says if both the bits are different, then the final result should be 1, otherwise it should be 0. Let's understand with 5 XOR 3. 5 in decimal is presented as 101 in binary, and 3 in decimal is presented as 011. Now XOR says if both the bits are different, then set it as 1, else set it as 0. So which means if we have 1 XOR 1, the answer would be 0 because both the bits are same. If we have 1 XOR 0, it would be 1. 0 XOR 1, it would be 1. 0 XOR 0 would be 0. Now here we can see the rightmost bit is same, so answer would be 0. 0, 1 different bits, 1. 0, 1 different bits, 1. So 110 in binary is presented as 6 in decimal. So we should get the answer as 6 here. Let's quickly check that. And you can see we got the answer as 6. The next one is Bitwise NOT. And before we actually understand Bitwise NOT, there is one more concept that I want to go over. That is the 2's complement. Because that's what Bitwise NOT uses, and if we don't understand that, you would not understand how we are getting the answers in decimal the way we are getting. So the two's complement is mostly used when we are using a sign presentation of numbers. When I say sign, I mean the positive and the negative numbers are presented. As we know that one, like let's say I'm using a 4-digit number system or 4-bit number system. So 0110 is presented as 3, right? So if I'm using unsigned system where I am not taking any negative numbers, all the bits will be used to present the positive numbers, which means if I use 1000, that would be presented as 8, right? That's what we studied. Or 1001 would be presented as 9. Okay. Now there is something called as two's complement to present the positive and negative numbers. So computers only understand in zeros and ones. There is nothing as negative or minus number like we present in our decimal system. If we want to present the negative number, we say -5, -6, -7, right? This minus is not presented as such in computers. There is no way to present it. So how we do it is using the two's complement. So what we do in the two's complement, we say the leftmost bit is would decide if the number is positive or negative. Let's say we take a 4-bit presentation, okay, and we are using a signed number presentation, which means we are using two's complement to present the negative or the positive numbers, right? So if the leftmost bit is 0, the number would be positive. And if the leftmost bit is 1, the number would be negative. Okay. So let's say 0110 would be presented as 3, right? 0111, I'm sorry, presented as 6, not 3. It would be presented as 7. Now plus 1, right? It would be 1000. In the positive number presentation, if we are not using two's complement, this would have come as 8. Now because we are using two's complement, the leftmost bit is used to present the sign. So if it is 0, then it's a positive number. If it is 1, then that's a negative number. So it would be presented as 0. And if I say +1, 1001, the leftmost bit is 1, it would be -1. 1010, the leftmost bit is 1, it would be presented as -2. Okay. So we will use the leftmost bit to present the sign of that particular number. Okay. So when we are using bitwise NOT, we consider that we have zeros or infinite zeros towards the left. And whenever I'm going to use the NOT, we will get the answers according to the two's complement method. Okay. Now let's understand what exactly NOT does. NOT simply flips the digits. So it makes 0 as 1 and 1 as 0. That's all it does. So that's why when I flip the digits, we consider that there are infinite zeros in front of any number that we are presenting. And when we do the bitwise NOT, it flips all leftmost zeros to 1, and that's why whatever presentation, if you are presenting the positive number, you will get an answer in the negative number. Let's take an example. Let's say I do print and I say not, I'm sorry, not 4, okay, and that should come as -5. I don't want to go too deep into it, how it does it, but you just know that because of this flipping of digits, the leftmost bits have been flipped to 1. And as per the two's complement, that would present the negative number. And let's say I do print not, and if I do any negative number, that's -6, you will see the answer as 5. Okay. Next one we would that I would like to discuss is right shift, and it is presented by this greater than symbol using twice. Before we go into example of right shift, let's understand how exactly the right shift works. So let's say 4 and I say right shift, and I will write number of bits I want to shift. And let's say, for example, just for the sake of example, I say 1, that I only want to move 1 bit. So for 4, it is presented as 1 0 0 because I'm going to move 1 bit, so I'll add 0 here. With right shift, all the bits would be moved 1 position, which means it would be 0 0, and it would be moved 1 position here towards the right, 1 0, which the answer would be 2 as per the decimal number system, right? So what it did, it added the 0 towards the left or shifted the bits towards the right uh, by by 1 bit, the number of bits that I presented here. So because I said 4, right shift 1. 1 is the number of bits you want to move. Number of bits you want to move. So this one is number of bits you want to move. Okay. Now let's see that as a demo, and I'll take the same example. I'll say print 4 right shift 1, and I will run it, and you can see the answer is 2, right? The same ways, let's say if I move 4 with 2 bits, which means if I say 4 right shift 2, which means I am saying that I want to move it 2 bits. So how would that work? So 4 is represented as 0 1 0 0. So if I want to move 2 bits, so it would be 0. Let's first move 1 bit, 1 1 0, and then again move 1 more bit, 0 0 1. I'm sorry. So the answer should be 1 because I have now moved 2 bits here. So 1 position, and then second position. 2 bits are moved towards the right. So the answer should be 1. Let's take that in our example as well and check how it looks. So I say 2, I'll run it, and you can see the answer is 1. The last one that we are going to discuss is the left shift, which is presented as the less than sign, and as the name suggests, similar to right shift. In right shift, we move the bit towards right. In left shift, we will move the bits towards the left. So I'll take same example again before I write the code. So let's say I have 4, and then I say 4 left shift 1. Okay. And 4 is represented as 0 1 0 0. And if I say left shift, I want to move the bits to the left side. And how many bits I want to move? Only 1, or only 1 position I want to move. So it will become 1 0 0 0, and that will become it. Let's check this with an example now. Okay, let's do print 4 left shift 1, and let's do that, and you will see the answer is 2. And if I move it by 2 bits, the answer would be quite large, would be 16, because it will again move 1 bit back. So what happened? So what happened is I did 0 1 0 0, which is 4, and then I say left shift 2, which means may move it 2 bits towards the left. So which means, let's say I move 1 bit, that is 0 0 0 1. Now I've moved 1 bit here, and then again I move 1 more bit, and the answer would be 16. Now 1 0 0 0 presented as 16 in the decimal. Before we wrap up types of operators, I just want to discuss one more thing, that is the bin function. So for now, when we discussed all the bitwise operators, we saw that we are getting the answers in decimal format. So what if you want to actually look at the binary format? So you can use the binary bin function. So what you can do is you can write bin, and let's say you write 4 and 3. Okay. And I will say, I'll print a message as well in front of it. Binary bits. Okay. I do this, and then I say print, let's say decimal format. Sorry. And I just say 4 and 3. Where is that? And I'll run it, and you can see it is giving me the presentation in binary 0b, and whatever after 0b is the presentation of the binary presentation. Let's say if I do 4 and 5, let's print it. You can see it is coming as 4, that is 0b100. So if you want to see the binary presentation of numbers, you can use the bin function. With this, we have come to the end of this video, and we have covered the bitwise operators, and also we have completed the operators in Python. From the very next video, we will start the condition statements, and we will covering the if statements in the very next video. If you like my content, please like, share and subscribe. I will see you guys in the next video. Until then, happy coding!